Now we're going to study a wave phenomena that combines constructive and destructive interference together. This phenomenon is called a standing wave. What you're going to see are two waves, one coming from the left and one coming from the right. These two waves are going to have the same amplitude and they're going to have the same wavelength, and they're going to pass through each other. Let's watch. Notice how it stops looking like waves are moving through each other, and it just looks like the medium is shaking in place. This is why it's called a standing wave. We're going to look at the standing wave a little more carefully now, and we're going to do this by turning on the ability to keep seeing the waves that are making the standing wave. So let's watch. Now you can see the waves that are moving through each other, and you see that they cause areas of destructive interference right here, where you can see this part of the standing wave is not moving at all. And then you can see this part of the standing wave is moving a lot. A standing wave is produced by the interference of two periodic waves that have the same amplitude and they have the same wavelength, and they're traveling in opposite directions. Now we know that there's two kinds of interference, that there's constructive interference and there's destructive interference. So let's look a little more closely at the standing wave by paying attention to the individual waves that are moving through it. And let's first of all notice that there are times like this where the two waves are almost completely lined up. And here I can see that the two crests of the waves are in the same place, and therefore the standing wave, the medium, has a very large maximum, and that's called constructive interference. And I can see constructive interference here too, with the two troughs are lined up, forming a really big trough in the medium, so that's also constructive interference. Now if I advance this just a little bit more, I can see that I also have times like this, where the crest from one wave is lined up with the trough of the other wave in exactly the same place, and you can see that it cancels out. And here again I have the crest of one wave and the trough of the other wave, and they are completely lined up, so they cancel out. So this is an example of destructive interference. So as the waves move through each other, at times the waves are in phase with each other and I have constructive interference, and at times the waves are out of phase with each other and I have destructive interference. However, those places, those types of interference occur at certain places along the wave. Well, I've learned that in a standing wave there's constructive and destructive interference that's going on, and I know that destructive interference is caused by waves canceling out, and constructive interference is caused by waves adding. But you know, if I look carefully, I can see there's something pretty interesting about destructive interference, and let me point this out. If we let the waves go through and we find these places where the waves are canceling, I notice that they always happen in the same place. And I can actually also see that there are multiple places where this happens. So let's watch as the wave goes through again, and we can see first of all that destructive interference happens at one location. Do you see that these points are not moving up and down at all, and that these locations of destructive interference do not move along the medium? They're stationary, and that's part of the reason that we call this a standing wave, that the destructive interference, once the standing wave gets started, the destructive interference is always located in the same place, and it's stationary, and this location is called a node. Nodes are areas where there is destructive interference going on, and that's why they don't move. And all the time that the waves are going through each other, The waves are always canceling out at those locations. So these locations are called nodes. But just like there's areas of canceling out of destructive interference in a standing wave, of course, there's also areas of constructive interference where they're adding. So let's pay a little more attention to those. I notice that here's one area that the medium is really vibrating up and down a lot. And there's more of them. I know there's another one somewhere in the center here where the medium really vibrates up and down a lot. And I also notice that there's even another one over here. And I notice that those areas vibrate a lot, but they do not move from left to right. Just like the nodes do not migrate from left to right, these areas do not move from left to right. And these areas of constructive interference, where there's a lot of motion, are called antinodes. So points where the displacements of the medium are largest, in other words, the medium is vibrating the most, are called antinodes.